Hello students, I hope you're all doing well and enjoying your vacation. I am Dr. Mohamed Ashour and this video is about a set of bachelor projects that I'm offering this year. These projects are camera-based plant status monitoring, infrared camera-based plant status monitoring, 3D camera-based plant status monitoring, and wireless deep soil moisture monitoring. All these projects fall under the title Intelligent Precision Agriculture, which is a very important and very updated topic that aims at enhancing the outcome of agriculture, which makes it very important for a country like Egypt, and it is very important worldwide. These set of projects, their objective is to either generate a product or to generate research. In both cases, students that are participating in these projects are encouraged either to generate research papers that could participate in international conferences or to compete in international competitions that deal with information engineering technology applications and in startup competitions and so on. In both cases, the competition or the paper, these are important items that would be very important for your CV and would enhance your competitiveness in the market. Let's first understand generally what is intelligent precision agriculture. Intelligent precision agriculture is interested to provide any plant with exactly the amount of water that it needs at exactly the time that the plant needs that amount of water. And it deals with problems such as when to water, how much water is needed, what is the effect of water on the plant. It is also one of their interests is to provide the plant with enough nutrients that the plant needs. And these nutrients, there's so many of them, and each one of them, as you can see on this image, will have a different effect on the plant. And the problem with these nutrients is that if you give the plant too much nutrients, that's not good, and if you give it too less nutrients, it is not good as well. These nutrients control the amount of crop that the plant will produce, the amount of fruit or the amount of vegetables that the plant will produce, how much will it grow, its ability to resist diseases and so on. So again, here's the problem of what nutrients are missing, how much to add, what is the effect of these nutrients and so on. It is also important to know very early on when there is a disease or a type of insect that is affecting the plant. And in this case, we are interested what is the current health of the plant, what type of disease this plant has, and so on, in order to be able to combat or to find a cure for this disease as soon as possible. How to achieve intelligent agriculture? The process is very simple. First, you need to monitor the plant. You need to look at the plant, see if there is any signs that it needs more water or it needs more nutrients or it has some diseases. And then you do diagnosis, which means that based on your monitoring, you know that, for example, you say this plant needs more water. And then you act, which means you give the plant more water. And you go back to monitoring to see if you have given the plant too much water or you still need more, and so on, and you keep going in these circles. This, of course, can be done either by a very experienced and hard-working farmer, which means that a farmer have to keep monitoring all the time the plants, and then he would have the experience to diagnose what are the problems. So, for example, he would have the experience to know that this plant needs, for example, calcium or needs magnesium or whatever, and then he would do that himself, and so on. This is not always very effective because, of course, the farmer is limited in terms of effort. He cannot check his plants every day or every hour or even every week. His ability to monitor every aspect is limited. and also his ability to link that action to a plant status, which means his experience, means that he needs to be very experienced in order to be able to do that. And such an experienced farmer would be expensive to have or to hire to run a farm. The other aspect, which is the more practical aspect, is to use electronic devices for monitoring. And this is the case. In this case, you use Internet of Things. So you use sensors and cameras and so on to do the monitoring part. And the advantage of using sensors and cameras is that you can do monitoring every minute, every 10 minutes, every hour. You can do as many as you want because these are machines. And you can record that somewhere. And then the diagnosis would be done by machine learning. So these would be machine learning approaches that use artificial intelligence in order to take the measurements that are done by the sensors and transfer them into diagnosis. And then also machine learning could be used to decide how much action to take. For example, how much water to add to the plant, or the amount of watering or the rate of watering that you need to do to the plant. And these are the main objectives of the bigger project that we are dealing with. In order to do that, the basic idea, as I said before, is that you have a plant. That plant would be monitored by a set of cameras and a set of sensors. These sensors would record things like temperature, light, humidity, CO2, and we also record the amount of moisture in the ground. And based on that monitoring and in this information would be processed by a machine learning model that would do the diagnosis that we talked about. And these diagnoses would also be used to decide what action to take. As I said, this translates into 4 projects, 4 bachelor projects this year. A project that deals with monitoring the plants in 3 different ways, and we'll talk about that in detail, and a project that deals with detecting the soil moisture in the plant. The first project is the camera-based plant status monitoring. This project makes use of a very small camera. It is actually an ESP32 camera, and the ESP is very similar to the ESP that you guys used in your internet project. The project would include setting up the monitoring experiment, checking the existing work on how to monitor a plant, use the ESP to take periodic pictures of the plant, and then send these pictures over a Wi-Fi to a server, and then use image processing and machine learning to basically do a monitoring of the leaves. So in this project, you will try to detect leaf edges like this one, and use these leaf edges to count the number of leaves of each plant, their sizes, their colors, because all these things are indicators of how good this plant is. This information would be used over multiple time intervals, let's say every hour, every day, and so on, to calculate how much the plant grows. So let's say we can count the number of leaves and see how the number of leaves increase over days. We can also increase their, calculate their sizes and see how the size increases over years, and transfer these into measures that could be recorded. These measures would be related to an already existing measurements of the environmental factors like the temperature, the soil moisture, and so on, to see how the effect of temperature, humidity, soil moisture on the growth rate of the plant. Another important aspect is to detect flowers, because flowers are indicators of how much the plant will produce crop, and would use them to predict the final outcome of the plant. This project is nice because it will prepare students to use or to know multiple things like image processing, machine learning, communicating with a server over Wi-Fi, and all these topics or all these skills are very important skills that could be used by any students in the future, and it is highly demanded by the job market. It is also interesting that students who would be performing well in this project might be encouraged to participate in competitions and maybe try to win prizes and so on. A second project which is similar to the previous one, but in this case we're talking about an infrared camera. And the importance of an infrared camera is that it can see things that we do not see. For example, the reflection of infrared from a plant can tell us how much water is contained in the leaves and so on. And that would tell us how much water does this plant need. In order to do that, we will need to transfer one of these ESP cameras such that they record more infrared, and then we will use different image processing filters so that we can produce an image of the plant that would tell us how much color or how the depths of the color of each of the plant scene colors, and use them to detect the amount of water. And in order to do that, first we will set an experiment. Of course, we will look at the existing work on this domain. We will need to do some handy work to convert the ESP32 camera to an infrared camera. We might use two ESP cameras, one to take infrared and one to take normal pictures so that we can compare them to each other. And then we use image processing to normalize the picture color, because one of the problems facing this project is that at different times of the day, the light would be different. So for example, how green is the plant would look from the camera point of view different. So we need to find a way so that we can measure all over the day, and that would be accurate. We would send this over a Wi-Fi, and then we would use machine learning to build a relation between the colors of the plant and the water content or the amount of water in the soil. And that would tell us how much water did this plant absorb, and consequently that would tell us if we need to add more water to this plant or less water. Again, this is an important project because in this project the student will learn first how to build IoT systems. And this is an example of the IoT system, the ESP cam. He will learn how to that IoT system can communicate to a server. And he will also learn image processing, which is very useful in so many applications. And then he will also learn machine learning, which is a very important topic that is in high demand in the market. So going through this project will give the student a number of very important skills that can enhance his or her chance of getting more jobs. The last project is similar to the two previous projects, but in this case, instead of having two-dimensional image of the plants, we will try to build two-dimensional images, three-dimensional images, I'm sorry. But these three-dimensional images would be built using two ESP cameras that are separated by a certain distance. And then this image would translate whatever these two into a three-dimensional model. That three-dimensional model will be used to measure things like the plant length, the number of branches, the branch and leaf orientations, the overall plant size, the rate of growth, and to predict the final plant length and size. These are all measures of the plant status and could be used to know how much we need for this plant in terms of water and nutrients. To do that, we will have to set a 3D plant monitoring experiment. We have to survey existing machine learning techniques that use 3D monitoring. We will have to synchronize the pictures from the two ESP32 cams, and we will have to send these pictures over a Wi-Fi to a server and build an abstract model of the plant, meaning build a silhouette of the plant, and from that model we can use this model to know these parameters. The last project in this set of projects is wireless deep soil moisture monitoring. That might seem a very simple project because you can find on the internet a lot of experiments and so on that actually connects an ESP to a moisture sensor. The objective of this project is, however, a little bit different. And the difference comes from the need to measure this moisture at different levels. So if we look at this picture, you can see, for example, that this area is very dry. This area has medium or low moisture. This is very high, and this is medium moisture. You can see that from how dark the soil is, because as you add water, the soil becomes darker. And that means that at some point we used too much water, that the water has gone to this level of soil, which is quite far from the roots of this plant. Current moisture sensors only measure whether there is moisture or not, so it cannot tell us that for example, in the first 30 centimeters, the moisture is medium, the next 30 centimeter it is high, and so on. And this is why it is called the deep soil moisture. So how will we deal with this project? We will start from existing work. So we will start from a normal soil moisture, which is available everywhere in the market, connected, and use it to measure the soil and see the effect of the moisture at different temperature at different depths on this sensor. And then we calibrate this reading. So we say if we measure this, then this relates to this level of moisture. The second approach would be to use multiple sensors. So we'd use, for example, 4 sensors, one at depths of 15 centimeter, one at depths of 45, one at depths of, for example, 60 centimeters, and one at depths of 75 centimeters, and so on. And take their readings and relate their readings to know the moisture at different levels of soil. However, the ultimate approach is to build a soil moisture that is, for example, 60 or 70 centimeter tall, and that would be able to measure this moisture at different levels. This is actually available in so many formats, and it could be done using sensors that measure the resistance between 2 points. So we would have different points, and we measure the resistance between these 2 different points at different lenses. And using this, we would know the amount of moisture at each depth. We can do it also using a capacitive sensor, which is very similar to the touch screens that you have, because the capacitance around the sensor would increase if there is more water. And that we can use to measure and these we could build easily using printed circuit boards. So we will have build our own moisture sensors and test them. This is a project that would be very interesting for people who like to work with their hands, who like to try new things, and who like to test a lot. It includes skills that are related to IoT. It also includes the skills that are related to creativity and basically inventing new things. This is a project that could easily compete in a lot of competitions. It is also a project that could be used to generate scientific papers that could be published in conferences, and that could add a lot to the students' career or CV in terms of having so much publications. By that comes to the end of the projects that I offer in this domain. I hope that you like them, and I hope that you pick them as part of your project. Thank you and have a good day.